In this workshop, we are going to study the effect of the passive flow control techniques on the separation control in the mixing elbow. And as you know that there are two types of the separation control mechanism. The one is active control, in which we have the control over the when we want to turn on that controlling mechanism. For example, the jet flow from the some holes, that we can control that the when we want to inject the flow through that hole, or we want to close that, that can be made automatic. For example, in on the onset of separation, that mechanism can be turned on and can be turned off when the separation is gone. So benefit is that for active control is that they will be used only, or the energy will be used only when we need them. But the passive control, they are simple to implement, but they have the disadvantage that they will be there forever whether you want them or not. But anyhow, the idea here is that if you know that we have solved the problem with this solar geometry, and you have seen that we have the separation control. So if I show you the vector plots, and you can see that we have the separation over here. So although with this swelling effect the separation has been controlled, for example we don't want to use this geometry, so in that case what should be done to control the separation on this part, and that is the topic of this video. Okay, so this file was generated in the part B, and the same file is now open here. So I will just delete these things from this workbench project, and also I will delete this solar geometry part as well, and I will just keep the full model along with the mesh, fluent, and the results. And now I will duplicate this geometry cell that as we did previously in the many cases on the mixing elbow. And here I will call this as a full model with bump at 15 degrees, and the diameter is let's say I will decide but let's say okay, I will decide that thing later on once we open the geometry. Okay, then I will put the name also at the end of this name. So double click on the geometry tab here, and this will open the space claim geometry and make it as a transparent. This is very important because we want to see the geometry from inside. And after that, click on sketching mode, and this time the sketching mode should be on the symmetry plane. So you have to work with okay, so you have to locate for the symmetry plane, and once you get it, just click there and then click on the plane view. Okay, so if you take a look here, so I'm saying the angle 15 degrees. This angle is basically is measured from here. This is my 0 angle, and this is my vertical angle or the 90 angle. So if the any angle which is, let's say, from here I make it 15 degrees, so this should be, right now it is showing 180 degrees. So 180 minus 15 is equal to, this will be equal to 170 and 165. So this is the 70 and 165. So this is the point where I want this geometry should be placed, that is a bump. And here I'm going to create the circle, and that circle is, let's say I put the diameter as 40 meters. Okay, so I will go back to that workbench project, and from there I will rename the file as 15 degrees because the angle is 15 degrees, and the diameter of this bump is the 40 millimeter. Okay, so right click here, and at the end of name say its diameter is 40 millimeter. Okay. Okay, now again we go back to the our space clamp window where we are making the geometry of the bump at the 15 degrees with diameter of 40 millimeter. There because we need this line for the making of the this whole sphere, and we use the pull command and choose this whole face, and make sure that you use the cut commands. There are two options. Either you can go with the no merge. If you use the add command, this will combine the inner part of this sphere with this main geometry of mixing elbow. So this will be gone because when we combine them, so the remaining part will be the this mixing elbow. And the only extra thing you will get is the outer part of the half hemisphere outside this mixing elbow. But if you use the cut command, this will cut the geometry from inside and then this will be deleted. And if you say no merge, so this will make the geometry of this whole full sphere and keep the geometry intact without making any intersection or interaction with the main geometry. So I would suggest that you should use the cut command. Otherwise, if you use the no merge, then you have to use the combine command to delete this part from the main geometry, and then you have to delete this geometry as well. So therefore, the pull command and the cut option selected. So I want to cut the geometry from this mixing elbow, and this is my axis of rotation, which is this axis, and that's why I was saying that the keep this geometry and then click on the full pull. Okay, as you can see that this has separated geometry from inside and then it was deleted automatically. And now we go to the 3D mode, and so now we are done with the geometry. Okay, so you can also now delete this line, and we can go back to the groups, and from here we have this wall small. Okay, I think we don't have the name for the wall large, this wall small. Okay, I think we don't have the name for the wall large, so I will be creating this name also. This is the wall large. And also we have the new geometry, which is the bump. So I will be creating the bump geometry as well. So this is the bump here, B-U-M-P. Okay, so now we are done with this geometry. So I will close this window and I will open this in the Ansys meshing. Okay, so I have created the mesh cell and double click on the cell F3, which is a mesh cell here. And this will open Ansys meshing, or we also call as a workbench meshing. And the only thing here we have to take care is the meshing properties or mesh sizing for the bump part, and as well as the in part as well. So just wait for the few moments so that this will load the geometry and the mesh setting and the mesh as well. Okay, so as usual, you can see some errors in the meshing. So simply choose the same commands and apply them on the geometry. So there is not much difference here. So this is the main geometry, and which is the body, and choose these four faces for the inflation, and also this should be also selected, which is the bump here, and body sizing would be applied again on the same geometry, and the face sizing would be applied on the small pipe wall and as well as this inlet boundary condition. So I would be choosing this geometry and apply. The only remaining thing is here is that the of this bump here, and for that I would be putting some sizing. So sizing for the face, and let's say I put the size as 0.0005, and I will enable the curvature and the proximity. So these two size functions should be enabled, and now simply click on the update or generate. As you can observe that the sizing on this geometry is very fine. So I think we should reduce size to some lower values. Let's say we try 0.001 and again create the meshing. This time it says still is a fine mesh, but this is different than the previously we had the very fine mesh. And also we need to check mesh, and also we need to check the section planes, and that would be the section plane where we can see the bump geometry along with the mesh. So I would choose this view, and I will use the plane, new section plane, and simply cut it from the center side, and also enable the whole elements. And now you can see this is how this will look like from inside. And you can see that the inflation layers, they are turning towards from the main geometry or the this wall arch towards the bump geometry. And same also we have this inflation on the smaller pipe as well. So now we have these required mesh sizing along with the inflation layers, and also very fine mesh on the bump. So now it's the time to run this case in the Fluent. We have created the cell for the Fluent, and before that, when we join these two cells, Fluent and the meshing, we need to update the meshing app in the meshing cell number F3. So after this is updated, we will transfer the mesh from mesh cell to the Fluent cell. And now simply transfer the mesh to the setup and double click here, and this will open the setup. And keep the default settings like the 4 processors, the single precision solver, 3D version, and the same error as we usually get. This is not an error, but this is a warning rather. And for that, go to the file menu and recorded mesh operations. Click on the mesh zone names and simply choose the two zones here and apply. And this is all we need to do here, because we have the different fluid elements or the volume elements. In the previous case, we had the only without the bump, and now we have the bump also. And simply close this, and just make sure that in the methods that every scheme has the second order. So momentum should be second order, and these schemes should also be second order. So turbulence is a second order, energy second order, and now simply run the calculation. This time this will also again initialize solution from scratch, and this will run 10 iterations, and after that this will run the required number of iterations, which are 400 here. And in my experience for the coupled solver, the number of iterations 300 to 400, they are more than enough, and that's why I will run this case maybe up to 300, maybe up to 400, depending on the residual plots. If they are in the straight line, I will stop solution. If not, then I will run this case for the 400 iterations. And you can see the solution is converging very nicely. And but I will wait for these plots to be in the straight line, including residual plots for the continuity equation, momentum, three components which are x, y, and z velocity, and the energy equation and the turbulence quantities. As you can see, solution has been stopped after running for the 400 iterations, and all the monitors and the residual plots, they are attending the required level of the convergence, as you can see here. And now I'm going to analyze, and first of all I'm going to analyze the control plots for the velocity, pressure, and temperature. And for that I need a one plane on the symmetry axis, and for that I will use the z coordinate, and that would be at the 0 z location. Okay, now from the control plot dialog box, I'm going to plot on the z coordinate 0, z coordinate 6, and uncheck the option for the global range and display. And you can also visualize the geometry of this bump here. And if I display the velocity, so still we can see that we have this large zone of the separation, and then the temperature. Okay, now we need to see the results in terms of the vector plots, and also I would suggest that you should be running the one more case with the bump at the 0 angle, and because separation starts after this side also. So I think that if the separation starting from this location, in that case you should be making the bump at 0 degrees, maybe, or maybe on the upper side. So you have to check the location, and in this way you can optimize the location of this passive control device for separation control. And now we display the vectors, and also draw the mesh for the bump, and yes, only for the bump, and display. So you can see that the separation has not been started from this location, as is very much visible here. And if I choose the vector option as a fixed length and in the plane, and now we have to change the scale to some lower value, maybe 0.005. So you can see that still we have some separation here. So if you change the location of this bump here to maybe up to the 0 degrees, and maybe you will notice that there is improvement in the separation. Okay, now that's the time to analyze the results side by side in the CFD post for these two cases. And for that I will close the case first, and then I will open the case inside the CFD post. Okay, now simply drag the solution cell on the results and double click on the result cell D2. So in case is the full model, and without anything else on the geometry, and second model is with the bump, and so this is without solar, that is the full model, and this is with the bump. And you can display the geometry for the bump as well, which is shown here. And I think that maybe separation has been increased because of the bump. So if you place it at the proper location, we can see the reduction in the separation. And as far as the pressure contours or the velocity contours or the temperature contours are concerned, you can see that there is not much difference on the mixing process. And also if we display the velocity velocity contours, and again I will not feel anything at all. So they are same. And if I go with the pressure, so we can notice some pressure change in the region for the bump. Otherwise, everything else is same. And if we display the chart plots, and this is the velocity magnitude, this is the temperature change, so it's almost the same. And if I display let's say pressure, they have the same trend, and maybe this is true for the velocity. Yes, almost same. So it means that this location for the bump is not optimum location. And if you want to get the benefits of this passive separation control mechanism or device, so you have to place this device on the optimum location, and also you have to place